the second example is a little bit more complicated than the first example. The question here is how many moles of H2O can be produced from 5.0 grams of H2? So our starting value is 5.0 grams, and we'll be solving for moles of H2O. So this is more complicated because we will not simply be doing a mole ratio because we don't have moles of H2. We have grams of H2. So again, just like in the first one, we have to figure out what kinds of relationships we have available to us in order to solve this problem. So we know that we are going to be going from H2 to H2O, and the only way that you can compare two different chemicals is in your balanced chemical equation. So we will have to, in this problem, use the relationship that 2 moles of H2 is equal to 2 moles of H2O. However, since we don't have moles of H2, we will need to convert our starting unit, grams, into moles by using the molar mass of H2. So the other relationship that will be necessary is that 1 mole of H2 is equal to the molar mass, which is 2.02 grams of H2. So since we have 5.0 grams of H2, and that's our given, we have to write this down first. 5.0 grams H2. And our first conversion is going to need to get us away from grams and get to moles by using the relationship 1 mole of H2 is equal to 2.02 grams of H2. So 1 mole is 2.02 grams, and we have 5 grams. So we can see already that we have more than 1 mole, but we're not sure exactly how many moles we have. Since we're starting with grams of H2, we will have to put the 2.02 grams of H2 on the bottom so that the grams and the H2 cancel out in our calculation. On the top will be the other part of our equivalence here, 1 mole of H2. So if we go through and do the math for that, 5 divided by 2.02 gives you 2.4752 moles of H2. I didn't round off significant figures at this point because I will only do that once I get to the very end of my problem. So now that we have moles of H2, now we can do the mole ratio between H2 and H2O. So for our second step, we're going to have 2.4752 moles of H2, and we'll be setting up our mole ratio fraction here. So we have moles of H2 at the beginning, we will need to divide by moles of H2. 2 moles of H2 on the bottom. We'll be solving for moles of H2O, so the 2 moles of H2O will go on the top. 2.4752 times 2 divided by 2, moles of H2 goes away, we get to moles of H2O, and the number is the same. 2.4752 moles of H2O. Now we're going to have to round off to significant figures. If we look back to the given in the problem had 2 significant figures. Our molar mass is more precise than that, so we will end up with 2 significant figures. 2.4 right there, so we get 2.5 moles of H2O. Now, you can show the work in 2 different steps like that, but one of the other conveniences of factor label is that you can stack the different fractions together. So what we can do is instead of doing the 2 different steps, we could have 5.0 grams of H2 times our 1 mole of H2 over 2.02 grams of H2. Instead of solving for an answer, I can just put my second fraction right on there. 2 moles of H2, 2 moles of H2O. And that will again equal your 2.5 moles of H2O. So either way works fine. You can either do one step, get an answer, figure out where you're going from there, do a second step, and get your final answer. Or if you can see where you're going with the problem, you can stack up all of your conversions together in order to reduce the total amount of writing that you have to do that. In the next example, we are asked the question, how many grams of H2O can be made from 10.0 moles of O2? This problem is similar to the last one because one value is grams and the other value is moles. However, in this instance, what we are given, our starting value is 10.0 moles of O2, and then in the end we will have to find grams of H2O. So let's figure out what relationships we will have to use in order to do this. First thing is we are going to be going from oxygen, from O2 to H2O. So we'll need to look at our balanced equation and get the mole ratio from that. So 1 mole of O2 is equal to 2 moles of H2O. However, at the end of this problem, we will need to have grams of H2O. So we'll also need to use the molar mass of H2O. 1 mole of H2O is equal to 18.02 grams of H2O. Simply adding together 2 hydrogens and 1 oxygen off the periodic table, you get 18.02. So we write down our given of 10.0 moles of O2. Our first conversion will need to get us from moles of O2 to moles of H2O. And by looking at the mole ratio there, for every 1 mole of O2, we will need to have, we will be producing 2 moles of H2O. So you can kind of expect that whatever we were starting with, we would be making twice as much water. We have to organize this based on the units, so moles of O2 will need to go on the bottom in order to cancel out. 1 mole of O2, and that's equal to 2 moles of H2O. I'm simply going to stack the next calculation right on here as I explained in the previous example. Once we have finished the mole ratio, we have arrived at moles of H2O. So therefore we're going to have to cancel out moles of H2O in the next fraction and get to grams of H2O. Since moles of H2O is on the top of our first fraction, we will have to cancel it out by putting it on the bottom of the next fraction. 1 mole of H2O will go on the bottom, and our molar mass of 18.02 grams of H2O is going to go on the top. You multiply your given by everything on the top of the fractions, and then you divide by everything on the bottom. So in this case, we're going to have 10 times 2 times 18.02. You could divide by the ones, but that's not going to do much to your answer. So 10 times 2 times 18.02 gives you 360 grams of H2O. So the decimal point there makes it so that 0 is significant, giving us the 3 significant figures that matches up with the beginning. In the last example, we are going to be answering the question of how many grams of O2 are needed to produce 25.0 grams of H2O. So this problem is going to end up being a little bit longer because we are starting with grams of H2O and we'll be solving for grams of O2. So we will not only need to do the mole ratio between H2O and O2, but we will also need to initially get from grams to moles, and then at the end, convert our moles into grams. So let's find out the relationships we have here. Going between H2O and O2, we can see that there are 2 moles of H2O produced from every 1 mole of O2. We're going to be starting with grams of H2O, so the first thing we're going to have to do is get from grams of H2O to moles, so the molar mass of H2O will be necessary. 1 mole of H2O is equal to 18.02 grams of H2O. So that conversion will allow us to get the problem started. Once we're done with the mole ratio, we're going to have to get from moles of O2 to grams of O2. So 1 mole of O2 is equal to 32.00 grams of O2. So we're going to write down our given first, 25.0 grams of H2O. Our first conversion will need to get rid of grams and H2O. The only conversion that we have over here that has grams of H2O is the molar mass. Grams of H2O will need to be on the bottom to cancel out, so 18.02 grams of H2O on the bottom, 1 mole of H2O on top. Our next conversion needs to get from moles of H2O to moles of O2. So our mole ratio up there is going to have to do the job for us. Since we have moles of H2O on the top, we're going to have to put the moles of H2O on the bottom to cancel out, and then the 1 mole of O2 on top. So that gets us to moles of O2. The question asks us for grams of O2, so we're going to have to use the molar mass in our last conversion to get from moles to grams. So this fraction is 1 mole of O2 is equal to 32.00 grams of O2. We already have moles of O2 on top, so we'll have to put moles of O2 on the bottom to cancel out, and the molar mass on top in order to get us to grams of O2. So if you go through and do the calculation for that, 25.0 is going to be multiplied by the 32 divided by the 18.02 and divided by the 2. If you plug those numbers into your calculator, you end up getting 22.2 grams of O2. That's 3 sig figs matching your initial number.